Hey everybody, we're back again. This is the second Ask an Engineer session of the day. I'm John Jennings.
And I'm Rick Perrotta.
Rick Perrotsky. Rick is the president of Rory Labs, former studio owner, one of the co-founders and main engineers at Matchless Guitar Amplifiers, was the president of that company for years. And we started Royer and Rick's Garage, and Rick and Dave Royer are co-engineers in every Royer product. And Rick is the reason that I like to call Royer Mike's Rick Perrotta Productions, because Dave's a great engineer and he comes up with great ideas, but Rick fleshes them out and gets them to that really tight place. So anyway, Rick is going to be answering your questions today. And if you'd like to send any in on the chat or any other way, call us on the phone. But anyway, we hope we can explain a few things about ribbons to you that you might not know.
Okay, let's go, John.
All right. So one of the questions that came in earlier that we didn't get to was, this guy says, I have 6 RCA ribbons. He's a ribbon guy.
Nice.
He goes, how do you make Royers so small?
Haha. Yeah. Well, when the RCA mics were made back in the 30s, the only available magnets were Alnico, and the only transformers were IE core transformers, and both of those were big and bulky. So when Dave started working on a modern ribbon microphone, we had the advantage of neodymium magnets, which are much smaller and more powerful than Alnico. We also had toroidal transformers and miniaturization of IE core transformers. So those two things primarily enabled us to move the technology forward. Then also having the ability to corrugate the ribbons in a different way with a direct corrugation method gave us a resilient microphone. So we could make it small and robust.
Cool. Well, we'll hit that corrugation thing in a minute, because that's kind of important. But actually, Rick, I didn't know that. I've seen those RCAs in like 77s and 44s. I'm sorry, the transformers in RCA 47s, 77s and 44s, and they're big.
Yeah.
And I know that's IE core, but ours are IE core in the 121s, and they are significantly smaller. So there's miniaturization of that transformer.
Well, not only that, they didn't have the ultra thin wire that we have now. They also didn't have the high permeability transformer cores. So we can make them smaller now with basically the same functionality of a much larger transformer.
Nice, because I know you have a much larger microphone in an RCA 44, but it's got about the same amount of output as a 121.
True. Yeah, and remember that at the time that the 44s were made, the tooling and the tools available to build them and construct them was not what we have today. We can do much greater things.
Gotcha.
In a smaller package.
Speaking of a smaller package, the transducer in a 121 is like, here's one, and it's a lot smaller, obviously, than the transducer, which is the motor in an RCA. Right. But the reason that you get so much crank out of that is these neodymium magnets that Rick was talking about. And I just want to show you how strong these are. I love doing this. I've probably done it like 1,000 times. But these are the magnets that go on 121s. And I mean,
yeah, they're pretty potent. You know what else, John? Besides the additional magnetic strength, we also were able to turn high ratio transformers so we can get more output that way as well, with low distortion. But yeah, the magnets are the big thing.
Yeah, and the only difference between some of the older and the newer 121s is we get stronger magnets and maybe get another dB of output.
Yeah, I think when we first introduced the R121 back in '98, we were about 4 dB less output than we are now, and that's just from the progression of the strength of the magnets.
Wow.
Yeah.
Yeah. They sound the same, don't they? I mean, is there any difference sonically?
No, no difference at all. Just output.
Right. Okay, let me look at the questions. Yeah. Somebody writes, Royer says you use steel for your microphone bodies. Why? That's a good question for you.
We do, and it's a real pain in the tail for us because we have to plate them, and it's because of EPA's restrictions. The plating isn't quite as good as it used to be, unfortunately. We're slowly moving away from plating altogether, as we did in the R10, which looks the same color-wise and texture-wise as a 121, but it's not plated. And what was the question, John? I forgot the question.
Just why did the microphones?
Oh yes, why are they made out of steel?
Yeah,
because the ribbon microphones are relatively low output. You're cranking up the gain quite a bit, which means that any induced noise or magnetic energy that gets to the transformer is also going to go down the pipe and get into your preamplifier. So the body of the microphone acts as a shield.
Oh, so like that thick body is keeping the RF from...
Not the magnetic, mainly
the
magnetic energy. Yes.
Got it.
Whereas a brass-bodied microphone would not do that. So given that you're using a lot of gain with a low output ribbon microphone, any noise, any radiated magnetic energy that gets to that impedance matching transformer would also be amplified.
And so then you just got noise.
Then you got noise. Yes.
Right.
Yeah.
All right. So I know in the R10, which is it's a larger body, but it's not as thick a metal.
Mm-hmm.
I understand. Like, I don't think we have the same body shielding here. How did you deal with?
Yeah. How did we accomplish that?
Yeah.
Well, first of all, the transformer is in a shielded. Here's an R10 that's naked. I don't know if you can see it. It's also missing the dampening screens, but the transformer is mounted in a mu metal shielded can. So the transformer itself is isolated. And also the turns ratio is lower. There's less output on this microphone. So it just behaves differently than a 121. Also, there's triple baffling around the transducer. So you got two screens that act as a bit of a shield for the transducer itself. So you still have some good immunity to noise with an R10.
Well, and being a guitar player, there's one thing that I always remembered about that. Like humbucking pickups because they cancel noise.
Mm-hmm.
And isn't that sort of humbucker too? Do you run the wires down?
Yeah, actually, if you look at the back of the transducer, you'll see two wires here. Those are it's called a humbucking winding. And that also reduces noise by canceling them out. They put any noise that comes in and is put out of phase with itself.
Ah, nice.
Mm-hmm.
All right, so there's like a few things going into that to keep the noise down.
Yes.
It's funny. It's a $499 mic,
mm-hmm.
but last Foo Fighters tour, it was the only mic on Dave Grohl's guitar cabinet for the whole tour.
Yeah, there's some advantages to an R10. As much as I love the 121,
me too,
because it's just a great mic. But the R10 has some advantages, and one of those advantages is that the transducer is shock mounted from the body of the microphone, and it's also the triple baffling and the larger diameter body makes the microphone much more resilient to punishment. In other words, it's almost like got a built-in pop filter. It also is less prone to damaging the ribbon from shock, whereas a 121 with the transducer mounted directly to the body and the microphone is more prone to damage if it's abused.
Or like if it's dropped or something.
If it's dropped, yeah.
Yeah. I mean, an R10's a great mic. I love it for a lot of things. I mean, side by side with the 121, I always pick the 121. But
mm-hmm.
If you're going on the road, or if you don't have $1,300 laying around, but you've got $5,
yep,
an R10 is fantastic.
Tonally, the R10 differs slightly. You could say that the 121 is a little more hi-fi. It's got an extended low end and an extended high end. But the mid-range in the R10, I think, is very special. Whereas the R121 is a little more even in the mid-range. The mid-range in an R10 is magical. and I think it's just, I don't know if that's by design or just by something came out from the heavens and said, this microphone will have a great mid-range. So they're different microphones. They sound a little different, but they both sound great. I would say that, the 121 we call a studio microphone because it's more, the bandwidth is wider, and the R10, which is every bit as good as a studio microphone, but it also excels for spot miking. Like a guitar amplifier, that's going to be a narrow band sound source anyway. So it works very well in a live situation, and that's what it was primarily designed around: abuse, loud sounds, spot miking.
Yeah. And it's like you said, sometimes you design a mic, you give it your best, and then, maybe even a few months after you've released the thing, you start finding out more about what it can do. Mm-hmm. I found that with the R121. It seems like 2-3 years after we opened, I'm still learning the microphone, or I was still learning the mic. And the same thing with the R10. You just keep learning it. With it's 5 dB lower output than the 121.
And that's to give it greater headroom and to minimize the chance of overloading the mic preamp. That was by design.
Yep.
Do you remember, John, when we first brought the R121 out and we went to a trade show? That was in '98. I think we kind of got laughed at, saying, "Why are you bringing ribbon microphones out?
Yeah.
Those are obsolete."
Yeah.
And what we didn't know at the time is, as the audio industry was transitioning from analog to digital, that ribbon microphones had a special quality that condensers and other diaphragm microphones didn't have. They don't have the drumhead resonances that those microphones had. So they translated much more naturally through the A to D process. And also the A to D converters weren't as good as they are today. So that kind of gave us the oomph at the beginning, and the microphones took off as a result of that. And that was an accident.
That was an accident. Yeah, it was a great piece of luck because, condensers going to tape would kind of soften and compress and sort of take the edge off
So those resonances actually helped as the tape wore the emulsion down. The brightness of those condenser microphones made it sound like the tape was retaining its high end.
Yes.
So what worked really great for analog actually didn't work so great for digital.
Right, because you record 7 or 8 different instruments on your condenser mics, and we're not condenser. We love condensers. Mojave is our sister company. All condenser mics. They're great. But in the tape world, you record everything on condenser mics and bring the faders up. Condensers all have that additive high end thing, and some of them are very bright and sibilant up there, and start taking your face off. And without tape there to help soften and compress that, the early days of digital recording were kind of rough on people. And then the introduction of ribbons right at that time was just good luck as far as we were concerned, because ribbons.
We would like to take credit for that by design, but it wasn't. It was just sheer good luck. And also the other factor was that when people started using condenser microphones for digital recording, they tried to EQ some of that sibilance out. But unfortunately, those harmonics are so complex that introducing equalization did not always cure the problem, and it added other problems that weren't there before. Right. Ribbon microphones, on the other hand, without those resonances, they take EQ extremely well.
Extremely well. We're going to have Russ Long with us tomorrow, who's a old friend, great engineer, who recorded the Sixpence None the Richer songs, Kiss Me and There She Goes Again, with highly EQ'd ribbon mics, because she was too sibilant on a condenser, especially in the digital world. But then she was great on a highly EQ'd.
It's funny, ribbon. I listened to that record yesterday, just scanning through my stuff, and
did you really?
I was like, wow, yeah, sounds great. And I even like the group The Laws that did that song too. I mean,
I do too. It was so cool. It had that kind of edge.
Both versions were good.
Yeah, I think The Laws version is great because it's just kind of edgy, and but hers is so sweet.
Yeah.
And it's a great recording. But there's highly EQ'd ribbons, and they just didn't mind being EQ'd like crazy because, like you said, they don't have all the artifacts going on.
Right.
Yeah. Okay. Well, that was a fun road to go down for a minute. Let's see what else we have here. We actually hit one of those questions already. What makes the R10 and 121 different? Here's the good one. Why are ribbon microphones figure 8? This guy says Bayer has a cardioid ribbon, and RCA used to have a cardioid ribbon, but why are most ribbon mics figure 8?
Ribbon microphones are naturally figure of 8, just by design. And to create a cardioid or a hypercardioid pattern on a ribbon microphone, which is what the Bayer is. Also, I think AEA makes a cardioid ribbon microphone. Those are basically the synthesizing the cardioid pattern, and frequency response is not very even in the cardioid position. And that's why we don't make one yet, because if we can't make it so that the frequency response is the way we want it, we'll just wait till we can.
Yeah. Good. Yeah, I know, like in the RCA one, they had baffling in the back, and I think there was like an acoustical labyrinth that was full of horsehair, and that would sort of cancel out what was on the backside.
Right, exactly. But then they sound, even though they accomplished the cardioid pattern, the frequency response was rather uneven.
Yeah, the same thing
with
with
served its purpose.
Yeah, it did. And what is it, the Bayer 160 that's got like 2 ribbons, and they're configured in some way to create a cardioid pattern?
Yeah, I'm not exactly sure, but it's sort of a labyrinth where you block off the back end of the ribbon.
Yeah, and sonically, it's okay for some stuff.
Yeah,
but it's not the full range ribbon experience. And the reason they're figure of 8 by nature is because sound's hitting them from the 2 sides. So if you hit it from the side, you total cancellation.
Right, total null point. Yeah.
Cool. All right, let's see what else. Why are ribbon elements made out of aluminum? Don't other materials sound as good? Why can't you use other stuff?
That's a good question. It just happens that aluminum is almost the perfect material for a ribbon element because it's very, very light and it has high electrical conductivity, whereas other materials, copper or whatever, are much heavier and would not respond to sound as well. There is one element that we've looked at, and that would be beryllium. But beryllium is very hard to form. Its electrical properties are not as good as aluminum, but it would be an interesting ribbon element if somebody could produce one. I don't think it would sound as good as aluminum. Aluminum just happens to be the best material.
It does. There was another ribbon material that we were looking at years ago that I know we put in a 121 and then did a side-by-side comparison, and the 121 with the aluminum was the clearly better mic. It just sounded much more
I think that material was a metallized nanofilm on top of mylar, and I don't think that as a ribbon element was as responsive as pure aluminum.
Yeah. Just for fun, for anybody, we're talking about ribbon elements. Do you want to see one?
Yeah.
Check this out.
Always want to know what they look like.
Like you've never seen one of these before, Rick.
Let's see. Oh yeah.
You see that?
That's a 2.5 micron thick by 3/16 of an inch wide ribbon element before corrugating.
Right. So is that in focus at all? Can you see that?
It looks pretty good to me.
Cool. See how light it is? I mean, there's really no wind in here, but just my speaking is making it blow around. So.
Yeah, when we're processing ribbons to turn a piece of flat aluminum into a corrugated ribbon, we can't touch them with our hands because the material would just stick. And when you're corrugating and trying to put a ribbon in a transducer, you can't do it on a windy, cold day because the ribbons float away. So yeah, they're very, very light.
What do you mean a windy, cold day? So like if it's windy outside, you're inside, you're not in the wind, but what is it?
What is it is the wind going over the roof of the building causes a static charge to build up, and the ribbons won't sit still. They want to dance.
Just because of the static electricity in the room.
Yes.
Wow. Cool. I remember coming in and seeing ribbons basically floating.
Yeah.
Not these, but the ribbons in the SF mics, which are considerably smaller.
They're thinner. They're 1.8 microns, 2.5 for the live version, and they're only about an inch long, less than an inch long.
Yeah. It's really interesting that you'd have to stack up about 40 or 50 of those to get to the width of a human hair.
Yes.
And they're so thin, but they can take some real, they can take some SPLs. And think about this, the Coles 4038, which is a mic we all love, ribbon,
Yep.
Much older ribbon. That ribbon is 0.6 microns?
0.6, yes.
So it's
real
literally
thin.
less than a quarter of the thickness of that ribbon I was just holding up.
Right.
Which is why if you look at those things the wrong way, they're blow.
They sound damn good.
Yeah, they do. That was the sound of Ringo.
Yes.
Pair of those overhead. Steve Albini used them on Nirvana, and from what I understand, was sending 2 or 3 out the door every day to get re-ribbon, but he just kept putting them up until they blew because it sounded good, and he still had them.
It's kind of like a race car, John. If you get the performance that you want, you don't mind replacing the tires every couple of laps.
Yeah. Right.
Same thing.
Cool. Well, got a question that just came in. Say, what transformers do Royer use? Are they made in-house?
No, they're not made in-house because transformer fabrication is requires a whole set of tooling and science that we don't have. We design all the transformers. David Royer designs every transformer that's used in the microphone. We don't design the output transformers used in the vacuum tube microphones because we use Jensen transformers for that. But all of the impedance matching transformers are designed by Dave Royer and made by an aerospace company that's got the capability to translate David's designs into a physical product.
Nice. Okay. We've got another question from Cy. Cy says,
Hi, Cy.
Hi, Cy. Sorry, you must get that all the time.
I wonder if he's into sci-fi.
Oh, this is bad. We apologize.
Don't go there.
We apologize. We owe you a discount. How do you manage to maintain consistency in the manufacture of ribbon microphones? What measuring devices are used and how?
Well, first of all, the people that make the ribbon microphones here all learned the process from David and myself. And it takes about a year of training and a certain type of artistic ability. You have to have good eye-hand coordination. You have to be very good with your hands because you're dealing with very small materials. And when it comes to building the microphones with consistency, we have built some electronic equipment that can actually measure the tuning of the ribbon as we're tuning it, because each ribbon has to be tuned to a very specific tension and to give it an elasticity. And it's not a tight tension, it's a very loose tension. And it's very difficult to get a loose tension correct. So we have some electronic equipment that enables us to position the ribbon between the two ends, their anchor points, at the precise tension that we need. And that's done by measuring, by sweeping. We energize the ribbon like it was a speaker, and then we monitor its resonant point with a frequency counter. And it'll tell us where the impedance rises, so we know exactly how loose or tight the ribbon is from that.
Yeah, there's some tricky stuff going on with the ribbons here. Real quick, Rick, your camera has gone off. Amalia, I know, had reset you once. So is she there?
She is. Sorry about that, camera people. Help, Amalia. Oh yeah,
Bring
I did
him
go
back.
He's back. He's back.
We go.
Really? Yeah. Okay. I'm sorry about that, folks.
Happens.
Technology.
So speaking about okay, so there's some fancy stuff going on with the ribbon element to set the resonance point and know that it's just right after it's been corrugated.
Right.
But it's interesting. How do you know if the ribbon? I guess you have to measure the thickness, right, to make sure that your material is right.
Yes, that's the very first thing. When we get raw ribbon material into the facility, well, first of all, you can't put it between the set of calipers because it's too damn thin, and you would just ruin the ribbon trying to measure its thickness. So what we do is we cut the ribbons to very specific sizes, and we weigh them with a balance scale. We have a balance scale that can weigh very, very light objects. So we know if a batch of ribbon coming in is where it's supposed to be in terms of weight, or if it's too light or too loose. And if the ribbon is too tight, too thick or too thin, it won't tune. It just won't tune. And you can't it just won't work as a microphone.
Got it. So that's cool. The way you know it's thick enough is just by weighing it. And if it
Correct.
weighs too little, it's too thin, or if it weighs too much, it's too thick.
Correct.
Cool. And speaking of thickness, John asks, why 2.5 micron? Why so thick? Why so thick?
2.5 is not very thick, John. It's actually quite thin. The RCA microphones were 2 micron. One of them was the availability of 2 micron foil. It was very hard to get. 2.5 was more of a standard that was available. It also was a little bit more robust than a 2 micron foil. We've actually ribboned up 121s with a 1.8 micron foil, and they sound wonderful, but you would not want to take them on the road.
No, and you could never put them on a heavy electric and stomp it the way you can with a 121.
And then while we're on the thickness of ribbon, a lot of times when we see ribbon mics coming from China, we dissect them because we're curious. And we find that most of them have ribbons. They'll say it's a 2.5 or a 2 micron ribbon, and we measure it, it's actually about 6 or 7 microns. So it's a lot, in many cases, I won't say all, but in many cases, the ribbons are much heavier than what they claim.
Do you remember the day we got a ribbon mic in and we took it, it sounded god awful. We took it apart and the ribbon was like cut at the top or something, but it was still sitting in the shape because it was so thick. It was
standing on its own.
Yeah, it was. It's crazy.
Yeah, I won't mention the brand name of that microphone, but I don't buy any of those.
No, neither do I. Yeah. Anika says she didn't know that Royer also sold dad jokes.
Bad jokes and puns.
Dad jokes. We're dad.
Yes.
Well,
sorry.
What are you gonna do? Yeah, sorry.
We've been making microphones too long. It's affected our brains.
So people can comment or write any other questions in the comment section, and then we'll come back and answer those.
Mm-hmm.
Man, it happened again. A half an hour just went poof. So
okay.
We're doing this again tomorrow. I think we're doing the Ask an Engineer at 1.
Okay.
You're doing something else about gain structure at 11.
Okay.
Tomorrow. So if you'd like to learn more, send me more questions.
We're going to talk about the debooster too.
Yeah. We're going to talk about that tomorrow. Yeah.
Yeah. Great. Okay.
That's for gain structure. So,
well, John, then I will see you tomorrow. Stay well in Nashville.
Thank you. You too out in LA.
Something. I've got a mask here because we have totally set up our facility for a safe environment, and I have a mask that has a face on it, so that when I'm driving around with my 2 German Shepherds, I look like one of them. Excellent. Okay. See you, folks. See you, John. See you, everybody.
Take care, Rick. Thanks to everybody for being a part of this, and send us any questions. We're putting them on a list. We'll get to them tomorrow, or join us again tomorrow at 1. And
sure.
Thanks for being here for this one. And we'll shoot for more dad jokes tomorrow.
All right. Take care. Bye.